Hello, everybody. I'm here with Bernd Wieswedel, and I don't think I need to introduce Bernd, since everybody knows him as the KNIME CTO. So Bernd, I've seen a bit of the new release, and frankly, it looks great. So I've seen the workflow coach to help you build faster and smarter workflows, the deep learning, the Tableau integration, the connection to the semantic web, and more stuff. So I'm sure that everybody here, like me, is curious to hear about it.
Thanks for the introduction, Rosaria. And I guess I will just start by giving some context. So as people probably know, we have released a new version of the KNIME Analytics platform very recently on 8th of July, and also a set of new commercial components. There's quite a long list of new nodes and enhancements and new features that we put in, which is too long to present them all here. There's more detailed information available on the web, and if you want to find about all the details, you have two choices. There's what we call the What's New summary page that kind of highlights some of those new features in a very user-friendly way. And if you want to get to the bottom of things, you can also look at the changelog that is linked from the What's New page that will list each and every change that we made to the software. What we want to do here in this webinar is just give a high-level summary of what we think are the most important changes that we made to the KNIME Analytics platform. And instead of me just presenting all of the new enhancements, we have asked some of the developers and team members that are involved in the development to present them here. Just to give people an idea of the agenda, so we'll look at some of the changes that we did to the workbench, for instance, the workflow coach that you mentioned, and then look at different enhancements in the analytics category, because this is naturally one of the strengths of KNIME, and then look at some of the integrations and utility nodes, databases, etc., and then move into the commercial extensions, including the KNIME server. And with that, I guess I will hand over to John, who is going to comment on the changes we made to the workbench.
Okay, thanks, Bernd, for the handover there. We've made several really cool improvements to the workbench with the new release. So the first one is what's next, the workflow coach. And the workflow coach allows you to us to recommend what node might come next in your workflow. So for example, if you already have a partitioning node and a decision tree learner, then based on analysis of community usage that you've agreed to give to us or choose to give to us, then we allow you to use the decision tree predictor and to see that that's the next most likely node in the workflow. So we can easily do that. And I'm just going to show a quick demo of how that will work. And so in my analytics platform, I'm actually going to show you a second feature as well that I'll come back to. And I'm just going to drag my workflow here from my workspace into my local workspace here. And then I get asked where I want to import that. I can choose Finish. And I can double click on my workflow coach example. And when I click on my decision tree learner, then I can see that my decision tree predictor is available here with 83% probability as being the next node in the workflow. And I can just double click that, and that will be automatically pulled into the workflow, and I can carry on with my workflow design. So that's really cool, and especially for new users, that can make the learning curve a lot easier. So there's three options of how these are built, either based on community statistics. We can analyze your workspace with the personal productivity tools, or you can provide those on a local KNIME server, which requires a KNIME server license. So you have three different ways to customize those recommendations to your liking. We have the automated installation of features. So that's if you open a workflow with a missing node, then we'll flag up that there's a node missing. And if you want to, then we can propose the correct package for you to install. So if you choose yes, then you'll see here that there was a Python script node missing and the Python integration is suggested to be installed. And what you might have seen when I demoed the workflow coach is that we had the KNIME workflow file, so the .knwf file, which was on the desktop, and I just dragged that into my KNIME Analytics platform. And when you install the Analytics platform now, you have the ability to choose which file extensions. So here the KNWF and the KNAR, the KNIME archive files are the KNR, and they contain multiple KNIME workflows. And when you associate those files with the KNIME Analytics platform, then they can be either drag or dropped into the workspace. You can double click to load them. And that makes things much easier just to get started with a new workflow that someone shared with you. And also we have the KNIME protocol, so we can embed links to KNIME servers on the web, and you can just click those and open the workflow temporarily on your analytics platform. So that's another super cool feature that just makes getting started and getting used to the analytics platform that much easier. So handing back to Bernd.
Thanks for this. And there's just another point why you would want to enable the workflow coach and submit some of the statistics and the information, what nodes you use in conjunction. So moving on into the analytics, this is by far the most, the biggest part of this webinar. And we have 3 categories here. And to start with, we have Adrian here, who's going to talk about feature selection and specifically forward feature selection, nodes and meta nodes.
So in the new version of KNIME, we have a framework for forward feature selection or feature selection in general. Some of you may know there have been backward feature elimination nodes, which could be used to eliminate features in a backward manner. And we revised those nodes and created new nodes that adapt the same loop structure, but allow for different strategies. So you can use a forward selection or a backward elimination. Now it is also possible to use flow variables as score, which gives you more flexibility as opposed to the old nodes. Alongside with the nodes you can see here on the side, there are 2 new meta nodes, one for each of the strategies that are listed here. So now I will show you a KNIME workflow about the feature selection. So what you see here is the forward feature selection meta node, and we will just jump right into it. Here in the beginning, you have the feature selection loop start. And in its dialog, you can specify which columns are your features and which columns should be static throughout the loop iterations. So we want our class column to be contained in every iteration of the loop. Then you can select your feature selection strategy. In this case, we will use the forward feature selection. And you can also specify a threshold for the number of features. So what the loop will do then is it will do as many iterations. It will do iterations until you reach the threshold limit. Good. In the feature selection loop end node, you can specify your score variable. In this case, we use the accuracy, and we need to specify that this is not a score that should be minimized. But if we would, for example, use the error here, then we would need to minimize the score. In the feature selection filter node, you can select which feature level you want to use. In this case, we will use the feature level that has 1 feature in it because it has the best accuracy. But you could also let the node select which feature level to use based on a threshold. Okay, that's all for the feature selection. And the next thing are enhancement to trees and tree ensembles, and the gradient boosted trees nodes that are new in KNIME. And first, we will talk about the optimizations for the random forest. We implemented the whole algorithm in a faster way, which should allow you to learn random forests on larger data. We also support binary nominal splits now. And up until now, you could only do multi-way nominal splits, but binary nominal splits are often considered to be better because they allow for more interaction between your features. We implemented missing value handling, and there is now also support for translation to PMML of regression models, such as the random forest regression learner and the simple regression tree. For the gradient boosted trees, first I want to give a quick insight what this actually is. Gradient boosted trees are based on gradient boosting, which again is a special form of boosting that is based on gradient and gradient descent. The prediction accuracy is very comparable to random forests and sometimes even slightly better. And it is used in data mining competitions on Kaggle and other platforms. We have nodes for classification and regression, which you can see here at the bottom. So we have a learner and predictor for both tasks. And here I will also show you a workflow. So this is the typical usage of those nodes. You have the learner predictor pattern that you will find in most of the machine learning nodes we have in KNIME. In the learner dialog, you can specify your target column and which are your features. And then you need to specify how deep you want to build your trees. In gradient boosted trees, you would use very shallow trees, usually, of maybe 4 to 10 levels. So this should be specified in here. Then you need to specify how many models you want to train and your learning rate. And the learning rate will dictate how much influence one tree has on the whole ensemble. The predictor node looks much like the random forest predictor node. So you can change the prediction column, append the overall class confidence, and append the individual class probabilities. So that's all for the gradient boosted trees and random forests in KNIME.
Thanks, Adrian. And while we swap seats, let me introduce David. David has been working on a new set of nodes, which are really exciting. Let's talk about deep learning.
Thank you, Bernd. So the new version of KNIME includes an integration of the Deep Learning for J library, which allows to use deep learning in KNIME. So first of all, the library which we used supports state-of-the-art deep network architectures and methods. The library also has CPU and GPU support, and GPU support is also a part of the integration. And another nice thing is that the networks are deployable on Apache Spark. So the integration consists of two main parts. So the first part is the deep learning in KNIME, which refers to all nodes used to create, train, and use deep networks. And the second part is about text processing with deep learning for J, which allows to create neural word embeddings. And now I'd like to talk about those two parts a bit more in detail, and we will start with the deep learning. So here the first step would be to create a network architecture. So in neural networks, the networks are usually structured in layers. So if you want to create a network, you would need to specify the amount and the type of layers you would want to use to create a specific architecture. Now in the KNIME Deep Learning for J integration, each of these layer types is represented as a own node. So if you want to create an architecture, you can just choose from a repository of layer nodes and connect them in order to create a specific architecture. So after the architecture is created, you need to train the network. This is done using a Deep Learning for J learner node. This node uses the previously created architecture and training data and performs training of the network using deep learning specific methods like, for example, dropout or rectified linear units. Then after the network is trained, you can use a predictor node, which takes in the trained architecture and training data, and this node appends output of the network to your table supplied at your input of the node. Then in deep learning, it is often very beneficial to share and save your networks. So there's also a reader and writer node to save and load your trained networks from and to disk. So next, I'd like to talk about the second part, which is about text processing with deep learning for J. So the library includes an algorithm to learn so-called neural word embeddings. So what are neural word embeddings? This is an algorithm with which maps words to meaningful numbers. These numbers are real valued vectors, and the dimensionality of these numbers can be specified by a user. And this would look like something like this. So we can create numeric representations of text. In order to do this, there are two available methods. The first method would be word to vector, which maps words to numbers. And the second method would be document to vector, which maps whole documents to numbers. So we have a representation for a whole document. Possible use cases for these neural word embeddings is to create input for deep learning, because these deep networks only understand numbers. And another use case would be, for example, document classification. So next, I'd like to show two demos of these two parts. And I'd like to start with the deep learning part. So here you can see a small workflow showing how a network is created, trained, and used for predictions in KNIME. So here on the left, we first create our architecture. In order to create an architecture, we need to use a model initializer node, which just creates a empty model where we can add layers to. Then in this case, we just create a simple multi-layer perceptron. So we add one dense layer, so one fully connected layer. Now, after we are satisfied with our network architecture, we connect it to a learner node. The learner node is also connected to training data. Here you can see the training data. In this case, the training data only consists of a simple two-dimensional data set, which is divided into two classes. Then we perform learning of the network, and the learner has a lot of parameters which can be adjusted, and these parameters can be adjusted in the learner dialog. Then after learning is finished, we connect the learner to the predictor node. Then the predictor node is also connected to test data. Then we can create predictions for our test data, and then maybe score it to see how good our model is performing. So next, I'd like to show you another quick workflow showing the text processing stuff, which you can do with the integration. So here we read in a data set consisting of some sentences. Then we want to create a representation for each sentence. Then in order to do this, we can use a word vector learner node, and this node is configured to perform document to vector. After the learning is finished, this results in a word vector model. So now to get to the actual word vectors, we can use a vocabulary extractor node, which extracts the words and the corresponding vectors from the model, which you can see here. So now the nice thing about these vectors is that similar words or sentences will have a very low distance in the resulting vector space, and the opposite for very dissimilar documents. In order to show this, I selected 5 sentences or 6 sentences from the data set, which you can see here. So there are 5 sentences which are very similar and 1 sentence which is very dissimilar. Then we joined those sentences with the corresponding word vectors. So here in this case, we configured our learner that the word vectors will have a dimensionality of 100. So we can use a PCA to reduce the dimensionality so we can display our resulting word vectors. This you can see here, and here you can easily see which dots correspond to the sentences which are very similar, which are here on the right, and the one sentence which is very dissimilar, which is here on the left. Okay, this was it for the deep learning part in KNIME.
Thank you, David. I think I have to make two more comments. First of all, this is work in progress. As you will find the deep learning integration in KNIME Labs. We continue to enhance it. And the second, I guess, even more important note is the credit goes to Deep Learning 4J, which is really a library that does all of it. And KNIME is just used to do the integration and to simplify the usage by offering a useful workbench tool. Okay, let's move on in our agenda, and let's look at some of the integration work and utility nodes that we added in the latest release. And let's start with some RESTful web service client nodes, and Vincenzo, who's going to present those.
Okay, thank you, Bernd. So we start with the RESTful web service client nodes. As part of KNIME Labs and following the famous KREST community nodes, the new release of KNIME Analytics platform provides new REST client nodes. These nodes provide a rich configuration and also an integration with KNIME XML and JSON processing capabilities. The nodes that have been developed are GET request, POST request, PUT request, and DELETE request. I will show you an example. So here we are. Okay. So, as I said, the REST nodes can be found in the KNIME Labs section. And under a subcategory called REST Web Services. So we start with using the GET request node, and we would like to show how to access data from the RESTful web service. So in particular, we use the World Health Organization's data, and we would like to get data on causes of death for high-income countries. So here in the configuration window, you can see the URL that we use to retrieve the data. So since the data are retrieved as XML, we need to convert this into table form. And to do this, we use the XPath node. So here in the configuration window of the XPath node, you can see all the data we decided to extract. So after some processing and aggregation statistics, we plotted the data using the tech cloud to show differences in the top 10 causes of death for men and women. So here you can see the results. In blue, there are the causes of death for men. In pink, there are the causes of death for women. And in green, there are the causes of death for both sexes. We can also plot a bar chart showing how these rates of death have changed between 2000 and 2012. So here you can see the results. And then in the bottom of the page, we would like to show how to combine multiple calls to web service using the GET request node. So here you can see all the URL that we give in input to the GET request node. And then as the data is retrieved as XML, we need to use again the XPath node. And then after a little bit of data processing, we plotted in a bar chart the leading causes of death between regions of the world. So here you can see the results. So that's all for the REST nodes. And now I would like to talk about the new semantic web nodes. So a again, the semantic web nodes are part of KNIME Labs, and these nodes allow us to query and manipulate semantic web resources such as DBpedia. And the usage model of these nodes is similar to the database nodes, with connector nodes, with query nodes, and with manipulation nodes. In addition, we also provide nodes for reading and writing various triple file formats. So I will show you an example also for how to use the semantic web nodes. Okay, here we are. As I said, also the semantic web nodes are in KNIME Labs. You can search for semantic web. And we start this workflow first connecting to DBpedia. So we use the Spark endpoint to connect to DBpedia. And then we execute the query to search for Simpson chalkboard gags. So here is the query. And then if you go in the query result table, you will see the data table, which has 3 columns: the season name, the episode of the season, and the chalkboard gag. So since we cannot manipulate the DBpedia semantic web directly, we need to put this information into a local memory. So we used for this the Spark insert node. And as example for manipulating semantic web, we delete all the gags that have less than 10 words. So then, as example, you see here the Spark delete nodes, which allow us to filter out all triples that are connected to a certain season, or to a certain episode, or to a certain chalkboard gag. In this case, we selected all these columns, and also all the triples are selected, which means that we have a match on all of the 3 columns selected. Then again, we use the Spark query node to retrieve the data. And here you can see the results. We have less gags, so gags that have more than 10 words. And then we use these results in order to plot all the data in a tag cloud using the text mining KNIME Analytics node. And here you can see in the tag cloud the results, which are all the terms that are most important in the gags that we have analyzed. Okay, that's all from my side.
Thanks, Vincenzo. If you want to learn more about it, you'll find an example online. Maybe I should mention that also, that we are about to upload a couple more examples to the KNIME public server that's nicely integrated into your KNIME analytics platform. Okay, let's move on in our agenda. And I'd like to comment on a new integration that we offer also now as part of KNIME Labs, which is an integration with Tableau. Tableau is a quite popular visualization and dashboard application. And we have received many requests from customers and users that we should offer an integration with that software. And also, so we approached the folks at Tableau to drive this integration, and we are also in touch with Forest Grove Technology. That's our, let's say, mutual partner in Australia who helped us to design those nodes and test and develop those nodes. The integration really consists of two different nodes. One is the what's called the Tableau writer, a TDE file writer, which writes what they call extracts. And the other one, a slightly more powerful node, is the send to Tableau server node that allows you to take a KNIME data set and send it directly into Tableau. There is not much to demo, but just to show you some of the nodes. So you find them in KNIME Labs. If you expand KNIME Labs, you see something the rest, so Semantic Web, and down here you also have the Tableau integration, and then you can just take any data set that you have and connect your Tableau writer, for instance. The dialog is pretty simple. You just choose the file that you want to write, and then you can write the file. The send to Tableau server is slightly more elaborated. If I connect this one here as well, open it up, then you have to choose where you want to upload the file, the username, password, so the credentials, some more information, and then it will publish the extract directly to the Tableau server. And then on the Tableau server, you can also have everything readily set up. You can design your template and then just feed it with new data. So you can do all of the pre-processing in KNIME, getting all the data into the right shape, connecting to different databases, Excel sheets, etc. So where KNIME really shines, and then just do the display in Tableau. The installation of the Tableau extension is a bit complicated, particularly on Windows systems. This is described here in the node description. Go through this. It's much easier on Linux and Mac systems, and we are currently working with the technical people at Tableau to simplify this and address some of the glitches that they have in their SDK. With that, I'd like to move on into databases and also the KNIME big data extensions. Those are quite connected. So if you are connecting to big data storages, then you often also need the KNIME database nodes. There are two important changes that we made. The number one is how you can add custom drivers to the KNIME Analytics platform. This is all done via the preferences, and you can just select the driver. Or now we also support that the user can specify a directory that is containing the driver plus additional files that are needed by the driver. This is, for instance, if you are using a Cloudera distribution and you want to use a proprietary native Cloudera driver, you could just point to that directory. So that's quite helpful. The other improvement that we made is a new node that's called Parameterize Database Query. It's a node. If you're familiar with the database looper node, then this is relatively similar. It allows you to parameterize your database SQL statement by means of a parameter table. So you have a set of, let's say, query parameters, and you just want to efficiently query your database given that, let's say, a dictionary table. And it's quite feature-rich. It's optimized for speed. It has the dialog that allows syntax highlighting and improved error handling, etc. So that's quite useful. If you are using the database looping node, also have a look at this new node now. And now let's move a bit into the commercial extensions, particularly the big data extension. And there are two different, let's say, subcategories. Number one is the big data connectors that allows you to connect to your big data storages using either the JDBC drivers, or here in this case, connecting to an HDFS data source, so the Hadoop file system. We already had a Hadoop HDFS connector node previously, but that had some problems, or it had some requirements how you connect to your HDFS drive. The suggested way is also to do this via REST protocol, and there are now two new nodes that allow you to do this with certain properties that are listed here. So I leave that for review separately. The other more important change is to the KNIME Spark executor, which is also a commercial extension that the KNIME.com company offers. If you have done any evaluations using the Spark executor, and you found yourself in a situation where this particular Spark version that we were supporting is not the Spark version that you are running, now it's a good time to have a look at it again, because we have modularized the whole integration and now support all the major Spark versions that are currently used, let's say, in the industry. The installation has been much simplified because of all these different modules, and we also defined a set of extension points that make it possible for third parties to contribute additional functionality to our Spark integration. For instance, to write custom nodes, and we have a partner in Italy, for instance, who has done that already. So there is a set of extension points available that allow you not only to use Spark, but also to contribute your own logic to this KNIME Spark integration. Yes, and with that, I'd like to conclude this on the big data topic. And now let's talk a bit about the KNIME Cloud Analytics and our cloud offerings and the changes that we made to the KNIME server. And I leave this to John.
Hi, thanks. So I'm going to keep the KNIME in the cloud section quite short because we have a full webinar available on the KNIME TV YouTube channel. So you can check that out in much more detail what's going there. And you can also find that in the Azure Marketplace. So why would you want to use the KNIME Cloud Analytics platform? And I think there's 3 really key points here. So first, you can get started really quickly. You can go straight to the Azure Marketplace and spawn an instance of the KNIME Analytics platform running on the Azure cloud. That means you can bring your analytics to your cloud-hosted data. So if you have a Microsoft SQL server or a big data offering there in the Microsoft Azure cloud, then you can run that straight away and connect to that from the cloud as well to get better speed and connectivity. And you can also scale your analytics workflow. In the case of Azure, up to 32 cores and 448 gigabytes of RAM, far more than is available on your laptop. So you can find this on the Azure Marketplace, the KNIME Cloud Analytics platform. And once you've found it, you can just click Create Virtual Machine. And you just need to step through a few steps, configure, choose what size you want to launch on. And finally, your virtual machine is up and running in Azure. You can click here on the Connect button, and that will download a connector, remote to the desktop connection file that you can then double click and launch. And then your KNIME Cloud Analytics platform is available in the Azure cloud, as simple as that. There's the KNIME Cloud Analytics platform webpage with a couple of guides. So launching the KNIME Cloud Analytics platform and also connecting to the KNIME Cloud Analytics platform. Both the quick start guides will help you get started. And also there's a YouTube clip of the KNIME webinar, Advanced Analytics, Scalable Churn Prediction Models, or Building a Churn Prediction Model in the KNIME Cloud Analytics platform. So you can watch that, and that's far more detailed than what I've just presented now. So moving on to the KNIME server, I'm going to focus on these 5 key points. So the web portal enhancements we've made, including JavaScript table view, file chooser, autocomplete. Then we're going to move on to the administration pages to make your admin easy, distributing license files for the advanced analytics platform, extensions, so such like the big data extensions and personal productivity, the KNIME server installer, and a very short bit on the extended REST API. So the first thing, the web portal enhancements, you can also use these in the analytics platform itself. In this case, we have a new JavaScript view, which is the JavaScript table view. And this is essentially a page table that you can scroll through your data, and it supports sort, search, and selection. And that was a sponsored development from Genentech. it's really, really cool and really powerful. We also have a new file chooser node that allows you to choose a file on the KNIME server that already exists there, as opposed to needing to upload that file. So if your files are already on the server, then you can allow users to choose from those files through the web portal, and that's really powerful. And again, that's sponsored by Genentech. So making admin easy for the KNIME server. So often we noticed that a KNIME administrator is often not a KNIME analytics platform user. So we wanted to make their job easier. And some of these standard tasks will be kind of keeping an eye on the KNIME server health or adding and removing new users. So you can do this when you log into the KNIME web portal by clicking on the administration button. That will load up this page here where you have the status, which shows how long the KNIME execute has been running and gives you what configuration details are being used. And you can also check which users are logged in and when they're active. You can check which jobs have been launched and which have executed successfully through the jobs page. And on the users and groups page, you can create new users, new groups, and remove users and groups as needed. And that makes things really very simple. And it's just a simple dialog that you need to do that. With the KNIME server license distribution, you no longer need to manually install license files on individual clients. If you have a KNIME server available to you, you can install all of the license files in the KNIME server so that they're centrally managed, and then users can check these out from the licenses view. And that just makes things really easy for new users to get started and use the features like the KNIME Teamspace or personal productivity or even the big data extensions. We also have the KNIME server installer. We've improved that and now have the installer available for Windows and for Linux. And this is a step-by-step guided server installation that walks you through all the steps you need to do to install the KNIME server and allows you to configure anything that you might need to configure. And that makes things really easy. And you can also then generate an automatic install script. So if you need to manage multiple KNIME servers, you can just run that script again and everything works easily. And finally, we have the extended REST API for the KNIME server. So that's just a quick point to mention that now it's possible to upload, download, delete workflows from the KNIME server with the REST API. And it basically enables many different possibilities for integrating the KNIME workflows into your IT infrastructure. And there's a couple of blog posts here for detailed tutorials on how to do that. So that's all for me about the KNIME cloud offerings and also about the KNIME server. So handing back to Bernd and Rosaria.
Thank you. So we have a bit of time for a few questions. I got one for, I think it's John. So somebody was asking, with the cloud product, is there a way to preset a maximum cost before running?
Yeah, so these are all possible through the standard mechanisms supplied by Microsoft Azure. And as you can just use all the standard mechanisms there to control your costs and manage that kind of stuff.
Okay, well, I think we are at the end. There are no more questions. Anyway, if you have other questions, you know how to reach us through the contact email, contact webpage on the KNIME site. So I think we will conclude here this webinar. Thank you, Bernd, and thank you to the development team at KNIME. And I would like to say thank you to you also for having listened to us for this great new release. Thank you, everybody, and goodbye.